Hello guys, this is Code and this is video editorial for the problem move brackets taken from Codeforces Div 3 round 653. So the problem is we are given a string of size n. Each of the character of the string are either left or the right bracket. In fact, there are exactly n by 2. N is even and there are exactly n by 2 opening brackets and n by 2 closing brackets. So what we can do is our final goal is to make the overall string a regular bracket sequence. I'm assuming that you already know what is a regular uh, bracket sequence. To make the string, if it is not already regular bracket sequence, what we can do, we can pick any character and remove it from its position and can send it either to the start or to the end of the string. So this is the only operation that we can perform, and we have to find the minimum number of moves required to obtain a regular bracket sequence. So basically we are given a bracket sequence which may or may not be regular. We have to find the minimum number of moves required to make the whole string a regular bracket sequence. To do that, what we can do, we can pick any character from any position and put it either to the beginning or to the end of the string. Using these operations, we have to find the minimum number of operations. So if we look at the example, these are some of the examples. So the first string is only this. So what you can do, you can take any of the character, you can pick the last one and put it in the beginning, or you can pick the first one and put it at the end of the string. So all you have to do is one operation. So the answer is 1. In the second example test case, the string is already regular, so we don't have to do anything, so the result is 0. In third one, what you can do is that take this one and put it in the beginning, so the overall bracket sequence would be regular. So the answer is 1. For this, what you can do, pick the last first 3 brackets and put them at the end. So pick the first one, put it at the end, put this take the second one, put it at the end, take the third one, put it at the end. So the overall string would be regular bracket sequence. So the answer is 3, because there is a minimum number of moves required to make it a regular bracket sequence. So how we are going to solve this problem? Since the string size can be as large as 10 to the power 5, I guess, so of course the algorithm must be of linear runtime. So one of the most important observation to solve this problem is this: if it isn't broke, don't fix it. Don't fix it. So what do I mean by that is that since our final goal is to make the whole string a regular bracket sequence, if some substring of the original string is already regular, we don't have to worry about them at all. For example, if you look at this, this is third example test case in the given problem. If you look at this example test case, you will see that the last 4 characters are actually already forming a valid regular substring. So what we can do, we can simply ignore these 4 characters. Now the remaining characters are actually the one which we need to take care of. And this thing, if it isn't broke, don't fix it. This thing is used in many programming problem. One of the example I can give you is, I don't remember whether it was 1 or 2 years back, there was a problem on Code Chef Long Challenge, string merging, strmgr I guess is the code for the problem. You can try reading that problem. That problem will be solved using dynamic programming, I guess. I don't remember, it was, I guess, back 2 years before this time. That's how early that problem was. So you can try solving that problem, and that problem also uses this hack. If it isn't broke, just don't fix it. So the problem name is string merging and the code is strmgr, I guess. So after this problem, I advise you to solve that problem as well, so you'd learn how really how common this thing is. So if any substring is already valid bracket sequence, we are not going to consider it. So whatever the string that we are left after removing all of the substrings which are actually already valid, so this is the string that we'll be left with, and the answer would be the size of this string divided by 2, because there will be exactly n by 2 left and n by 2 if the size of the remaining substring is, if the size of the remaining string is n, then there will be exactly n by 2 opening and exactly n by 2 closing brackets. So moving all of the opening bracket, or sorry, moving all of the, either all of the opening bracket towards the beginning will take n by 2 operations, and all of the closing bracket towards the end of the string will also take n by 2 operations. So the result will be n by 2. So all you have to do is remove all of the substring which are actually valid. Now the question is, why exactly n by 2 would be the solution of this string? First, you must be very clear, it must be very clear to you that we don't need to take care of all of the substring which are actually already valid. So whatever is left, we only have to take care of those substring. So after removing all of the valid, whatever we are left with will have exactly, if the length of this string is actually n, then exactly half of them will be opening and half will be closing, and they always be in this form. First n by 2 will be closing brackets, and then n by 2 opening brackets will be there. And I want you to prove it yourself. It would be as an exercise why, after removing all of the valid substrings, the remaining string will contain half of the closing bracket. First half will be the closing bracket, and the second half will be the opening bracket. And if we are left with this, of course the result is going to be n by 2, because all you have to do is transfer the first half to the end, or the second half to the beginning. So that is why the result would be n by 2 after removing all of the valid substrings. Now the question is how you can remove valid substring. This can be done using a simple stack, and there is already an algorithm, greedy algorithm, I guess. It is called bracket sequence stabilizing or something. I don't actually remember the name of the algorithm. I'll be posting the link of how you can actually remove all of the valid bracket sequence from the given string. So to do that, I'm also going to explain it here. So what we are going to do, we are going to scan the string from left to right, and we'll use a stack. So what we are going to do, whenever we are going to get the first character we get is a closing bracket. Of course, when you get a closing bracket, you would see in the stack, is the top element actually a opening bracket? So the answer is no. So if the answer is no, of course you are going to insert it. Similarly, for the next element, it is again a closing bracket, so you would see whether the top of the stack is actually a opening bracket or not. The answer is no, so you would insert it, again insert it. Now whenever you find an opening bracket, of course you are going to insert it without any condition check. So I'm going to insert from here to here in the stack in the same order as they appear. Now we are at this element. Now since this is a closing bracket, so in the stack we'll see whether the top of the stack contains actually an opening bracket. So yes, it does contain the opening bracket. So what you are going to do, instead of inserting it, you will be removing this. So this character is removed. So now we are on this character. Again, this is a closing bracket, so in the stack you will see whether the top of stack is actually an opening bracket. Yes, it is. So what you are going to do, instead of inserting, you would remove it. Now you have scanned the whole string from left to right. Now whatever is left in your stack is actually the remaining string, which we need to take care of. So this is how you would do it. So if I show you the code, so first I've taken a character array of size, I guess 10 to the power 5 or 10 to the power 6, and after that in each test cases we are reading n and inserting, basically reading the input character string. Now this is a for loop that runs from 1 to n, so I'm using 1 base index system. Now after that we are calling getAnswer function and printing half of that. So of course it is returning the size of the remaining string. That is why the answer is size of the remaining string divided by 2. Now what we are doing here, it is simple. We are taking a stack which will be storing character, and we are scanning the string from left to right, and if the ith character is of course the opening bracket, we are going to insert in the stack without any condition. Otherwise, if it is closing bracket, we would see whether the top of the stack contains an opening bracket or not. So if the top of the stack contains an opening bracket, and of course first thing you check is that stack must not be empty. If the stack is not empty and the top of the stack contains the opening bracket, of course we are going to remove that character from the stack, otherwise we are going to insert it. And finally, we are returning size of the stack, which will contain the number of character which we need to take care of. And this is how you solve this problem. If you have any doubt or query, of course you can ask me in the comment section, and of course I'll be putting the link of the algorithm. Bracket balancing or something like that is the name of the algorithm. I'm not very good with remembering the name of things, so I'll be putting the link of this algorithm that we are using to remove all of the substring which are actually valid bracket sequences. This is a greedy algorithm, base algorithm. So I'll be posting the link of that algorithm in the description as well. So this was all for this lecture. Thank you guys for watching. Until the next video drops, keep coding. Thank you.